Okay, one of the things we talked about in class, and it went by really quickly, is there's a way that I can know, there's like a little memory device that can help me summarize which trig functions are positive in which quadrant. And you start in the first quadrant and you go all students take calculus. And that's your memory device. And what that tells me is in the first quadrant, all the trig functions are positive. This tells me which trig functions are positive. All trig functions, I'll just abbreviate that YFXS, positive. So it doesn't matter what it is, it's going to be positive in that quadrant. In the second quadrant, S tells me sine is positive, and then since it's positive, it's also its reciprocal function cosecant would be positive. So I can know the sign of these things. That's going to be more important as we go along. In the third quadrant, you've got the T for take. That tells us the tangent is positive in that quadrant, but nothing else is positive except for the tangent and its reciprocal function because we're just flipping the function. The cotangent would also be positive. We'll see this again in 4.3. The C for calculus stands for cosine is positive in that quadrant, and also its reciprocal would be secant is positive. That's going to help me a little bit with 49. 49 to me is the hardest problem to do without knowing section 4.3. To me, 49 is the hardest problem in section 4.2. All right, so let's think about where we're at, and I'm going to use that all students take calculus. My sine function is 4/5. So I know that whatever angle T I'm talking about, it's either here or it's either, sorry, not down there, it's either here or here. It could be in either one of those quadrants since it's positive. Now, what they want me to do here is think about, I'm going to have to look at both cases here. What would happen if I have a positive sign? Let me start with B first because the B part is easier than the A part in my opinion. If I'm, let's say I'm in quadrant 1, I'm going to think about both of these situations. So I'm going to start here. If I were to add pi, that would be going halfway around the circle. So if I were to go 90 degrees, I might jump over here. If I were to go 180 degrees, which is pi, I would end up here. So if I look at it, is sine positive in that quadrant anymore? It is not. It's over there where the only thing that's positive there is tangent. So I know this is going to be, it's going to have a negative sign there, and it's going to be 4/5. Let me look at the other case. What if it had been here and you added pi to it? You would have gone 90 degrees, 180 degrees. You would have ended up over here somewhere. And again, is sine positive in that quadrant? No, only cosine and its reciprocal are positive. So that means no matter, which original case I looked at, it's always going to be negative, okay? That's the B part. That was easier to me than the A part. Let's look at the A part. I'm going to actually go to a new, let me just do another drawing and try to keep it on this page. Sine of pi minus t. It's either going to be 4/5 or negative 4/5 is basically what we're trying to see here. Let me write all students take calculus. Now, if the sign originally, again, was 4/5, it was either in this quadrant, which I'll put as a red bump, or I'll put it's either in this quadrant. So either one of these is where I could have started. What happens if I subtract pi? Okay, if I subtract 90 degrees, that puts me in this quadrant. But if I subtract 180 degrees, which is what pi is, it puts me down here. So it looks like if I take pi and subtract t, no, that's not what I need to do here. This is why this one, I left it for a second. I'm having a hard time with it. All right, whatever it was either in one of these two quadrants, right? Now, where's pi? Pi is, let me get purple here or something. Pi's right here. Both of these quadrants, if you think about the angles in them, they're all less than 180 degrees. So let's think about this as 180 degrees minus the angle. And let's think in degrees. It'll be easier to think in degrees. If this obtuse angle here, that I like the green one, let's take the green one first, which I should probably make green. Here it is. If I take 180 minus this green angle, I'm still going to be, have an acute angle left. It's still a positive result, which will put it over here in this first quadrant where the red dot is. That's where I'd end up. If I had 180 minus this green obtuse angle, I would end up with quadrant 1, and all things are positive in quadrant 1. So this is actually going to be still a positive 4/5. What if I started off, though, in quadrant 1? What if I had a little angle and it looked like this? And I subtract that from 180. Remember, 180 is way over here. If I take 180 and I cut that little bitty angle out, like let's say that's 20 degrees. Well, 180 minus 20 degrees would be 160 degrees. That would put me over now in this other quadrant right here with my resulting angle that would be going on. You have to really think a little bit abstractly here. Maybe putting a number with it is more helpful. That still, sign is still positive in that quadrant. So no matter whether I looked at the angle starting in the first quadrant or the second quadrant, when I subtracted it from 180 degrees, the resulting angle was still either in the first or second quadrant. So this is actually going to be a positive 4/5 here. The mistake that I made earlier when I started going around backwards, that would have been the angle minus pi, but that's not what it told me to do. That's why I have those green squiggles there. The mistake I made in my thinking when I did that was I was trying to say take the angle and subtract 180, but that's not what it said. It said take 180 and subtract the angle. So if you maybe now you can understand why I made that mistake, if that was your kind of first instinct to do too. It was definitely my first instinct, but then I realized I was doing it backwards. Anyway, that's how you would do 49. It'll get easier to think about that after 4.3.